Right, now we have a model for a binomial distribution. It's fairly reasonably easy to calculate probabilities. So we've got this question here, the random variable x, we don't know what it is. It's binomially distributed with n being 10 and the probability of success being 2/5. Find A, the probability of x being equal to 5, the probability of x being equal to 8, and the probability that x is at least 2. Okay, we'll have a look what that means later. So we've got x is binomially distributive, n is 10, probability of success is p, which is 2/5. So that means n is 10, p is 2/5, and we can calculate q being 1 minus 2/5, which is 3/5. Remember, these two add up to 1. So in the first case, we've got the probability that x is equal to 5. And the probability that x is equal to x is ncx, p to the x, q to the n minus x, where q is 1 minus p. So that's going to be 10c5. The probability of success is 2/5 to the power of 5, and then 3/5 to the 10 minus 5, so that's n minus x. X is 5, look, 5, 5, n minus x, p, q. That's 10c5, 2/5 to the 5th, and 3/5 to the 5th. Working that out on my calculator, on these modern calculators you can put fractions in quite easily, and you can put combinations in using this one here. Fractions you can put in by using this one, and you need the power symbol as well, and brackets. Have a play with your calculator, make sure you can do it okay. The calculator gives that answer. It's good to write a few numbers out first. So 0.2006581, and then round off to 3 significant figures underneath. So get into the habit of writing down the full calculator value and then rounding off. B, the probability that x is equal to 8. So using this is going to be 10c8, 2/5 to the power of 8, 3/5 to the power of 10 minus 8. So that gives 10c8, 2/5 to the 8, 3/5 to squared, 10 minus 8. Then on my calculator, same sort of 10c8. Now if you've already put it in once, then you can use the replay button to go back to edit the 5, the power here, and the power here. Okay, so that's another little time that might save you a little bit of time in the exam. Once you set it up once in your calculator, you can go back and edit it. So that gives me 0.0106168. Round off to 3 significant figures. Remember that 0 is not significant. So 0.010623 significant figures. Right, the last case. Probability when x is at least 2 means 2 or more. So we want the probability of x being greater or equal to 2. Now to do that, you have to consider the probability of x is 2, x is equal to 3, x is equal to 4, x is equal to 5, x is equal to 6, x is equal to 7, and x equal to 8. So we've got rather a lot of probabilities to calculate there. So it might be easier to calculate the probability that x is greater than 2 as 1 minus the probability x is equal to 0 minus probability that x is equal to 1. So it's going to be n is 10, p is 2/5, and then q is 1 minus 2/5, which is 3/5, which is going to be 1. Q to the 10, 10c1, p, q to the 9, so it's going to be 1 minus 3/5 to the 10, minus 10c1, 2/5 times q, which is 3/5 to the power of 9. That was that on my calculator, so we've got quite a few because it goes across a few screens. And that gives that answer. Again, writing out the full calculator value and then rounding off to 3 significant figures. Also useful is this. Probability that x is at least 1 is probability that x is greater or equal to 1, and can be found by 1 minus the probability that x is equal to 0. Another quick way of doing that type of problem. Okay, this has been a video to show you how to calculate probabilities using the binomial distribution. I hope you've understood, and I thank you very much for watching.